Hello everyone. Today I want to show you something that I have built on my home network, which I think everyone should really have. Before building my home lab, my home network looked like a normal traditional household setup that you can see on the screen. The ISP modem or the router is directly connected to the internet, and every device in my home was connected to the same LAN network. So this is my LAN network, which is your local area network, and I'm getting internet from the WAN. This is how traditionally all homes are. So be it your phones, laptops, smart TVs, IoT devices, even your CCTV cameras that you think only you have access to, everything else are all sitting in one flat network. This setup works fine for basic internet usage, but from a security and networking, cybersecurity risk perspective, it has limitations. There is little to no separation between devices. There is limited control, and if one device gets compromised, it can potentially communicate with everything else on the network. This is particularly true because the kind of IoT smart devices that we use in today's modern world, they are not tested for the level of security. We don't know what they're doing in the background. All we know is we allow them full internet access to our home. It is like allowing a stranger access to inside your home physically. Your home network is your digital home, so it's your digital home network. So allowing someone to have full access to your home, to roam around inside your home, you don't want that to happen, right? That is what exactly we achieve with what I'm going to show you in the next slide. So this is what I have set up in my home. I redesigned the network using OPNsense and segmented the entire set of devices that I have online in my home in 3 separate networks. So there's network 1, which is called the IoT network. The second network is my NAS, which is my network attached storage, which is like a cloud storage, private cloud storage within my own home. And then this is my third network, which is basically my trusted devices VLAN. So instead of one flat LAN, I have isolated segments for different types of devices. This is my main trusted network. I have a separate IoT, and I have another which is just for my NAS. Now, using VLANs and firewall rules, I can now control how traffic moves between these networks. This gives better security, better organization, and much more visibility to what's happening inside the network. So imagine if you have an IoT device which is connected only through to this Wi-Fi, it's only going to get an IP address in the range of 10.0. And by the way, the world standard is that any IP starting with 10.0, 172.16, and 192.168 is a private LAN, is a private network IP. Everything else is a public IP. So I've used this appliance, which I'll post the link, and installed OPNsense Firewall on it. The WAN internet connection through the cable goes into this Ethernet card. And I will show you in a demo now that how I have configured the 3 interfaces here and assigned 3 separate IPs to it, and basically configured it into the access point mode, AP mode. So any device that is now imagine connecting to the IoT Wi-Fi network, which is a smart plug or switch or a light or a camera, it does not have access to my devices. And likewise, if there is any device which I have, which is my trusted network, I have allowed it to be able to connect to the NAS and to the IoT because I know what I'm doing. So basically, I have highest level of permissions given to my own devices which are connecting to this LAN, but least privileges given to the IoT network through the segmentation. So let me show you in the demo how I've achieved this. All right, now that we know how our target network setup should look like with the segmented VLANs in the home network, let's see how we actually achieve it through OPNsense. So I'm going to log into the network to the OPNsense admin UI using the HTTPS 192.168.1.1 IP with my root username and password, and that's what I get when I log in. So that's my dashboard. As you can see, it's already providing me a lot of meaningful information about what my network has been going through over the last few hours, all the traffic information in and out, etc. But let me just start with what is the first thing you would do when you would actually want to set this up. So you would actually go into interfaces and go into assignments. So this is the point where you only connected your WAN cable. And you would click on device list here. And as you see, I've already configured IoT LAN NAS, so it's already showing up here. But when you do it for the first time, it will show these drop downs over here in the device. All you do is select the value. For example, you want your port 1 to be WAN, port 2 to be NAS. So you select port 1, give it a name, and click on add. When you do that, it will show up here. So that's what that's literally all I've done. I've selected the device and given it a name and click add, and it shows up here. After that, what you do is you click on each device, for example, IoT, enable it, tick this box, and all you do is specify what will be its static IP configuration. So it is 10.0.0.1. Likewise, for LAN, I am giving it as 192.168.1.1, and so on for the NAS, which is my third network, which is 172.16.0.1. And that's pretty much it. After doing this, you will see this icon initially will be red, but it will turn to green. You connect the cables, after that, it will turn green. That means it has started giving the IP addresses to devices which are connected to this LAN. What you also need to do is define your DHCP range. So you go into services, go into DNS mask, go into DHCP ranges. So as you see, there are 3 networks in your home now. So you would click on add, By clicking plus, I'm clicking on edit just to show you. And you choose the interface. So you choose LAN, which is the interface you created in the previous step. You specify the starting address range and the ending address range. Click save. Repeat that for each of your network. So I choose the interface as IoT, specify the start and end. And lastly, I specify my NAS interface and my start and end. As you can see, I've only got 4 IPs as the higher limit for my NAS because my network attached storage has 4 network ports, and I really don't need a 5th port. I really don't need a 5th IP in this network range because there can only be max 4 devices that can connect to it. So I've given that range, and that's pretty much it. After doing this, when you connect your cables on those ports, you will automatically start to see the traffic which we were seeing here showing up. Right? You can go into reporting, go into health. It's going to give you even more meaningful information. You could choose the network you want to monitor. For example, if I choose WAN, it is telling me what has been the activity in terms of packets, in terms of the services, in terms of the system. All this level of information, detailed level of information now per type of your network is available. So I can check what my activities has been on the LAN. How has my LAN devices been operating over the last 24 hours? Okay. There's this whole range of information. For example, I go into insights now, and now you can see I could choose the history back up to last 1 year or so, or I could choose last few hours, and then it tells me for each of my LAN, WAN, NAS, IoT, and even my VPN, which we'll cover later, what sort of traffic has been flowing through. What are the IPs? As you can see, these are all the IPs that have been trying to communicate to my network. So this is the WAN interface here. I could go to LAN, and then it is telling me, as you can see, all these IPs 192.168. This is our VLAN we have created. This is my devices, right? They are trying to connect. I can see which is the highest consuming, which is the IP ending with 187. Later, I'll show you how do you deep dive into these specific IPs. It's showing you which are the most ports in demand and highest used. So as you can tell, it's TCP is the most widely used port in my LAN. I go to IoT, and that's the state of my IoT. As you see, all my IoT devices have been assigned at 10.0 IP range. And who's the most highest consumer in my IoT network? It is 10.0.0.155. And what is this? This is my Home Assist. So this is the Tapo device that is running on my Home Assist, the hub, which is consuming the most of the traffic. So that's the kind of details it will give you. I could go into traffic, and it shows me you choose which interface. If you want to monitor only one or all, I've chosen all. So for all the interfaces, it is telling me real-time traffic, what's happening on my internet. Just to give you an example, I open speed test, and I give it a go. And the moment I start speed test, you'll see that there'll be a big spike coming from the WAN network now, because it's sending hundreds of bytes of data over the internet. So that's the kind of live traffic information with what IPs are trying to do, what is being shown. I could go in top takers, and again in top takers, it's going to show me all the internal and external IPs who have been utilizing and using my network. So that's just to give you a simple glance of what it is capable of. In my next section, I will cover what it is like to put up firewall rules and how do you actually monitor your traffic in real time and block specific IPs, watch the activity within your home network, and try to do some forensic. And I'm sure when you do this, because when I started doing this, you will find that there were dodgy IPs which were actually residing in my home network, which were randomly created and generated by one of my IoT devices, which I didn't know, and they were sending traffic outside. I don't know what they were transferring. So I'll set up firewall rules to block them, which I will cover in my next section.